What are the different conditions? The different conditions are high temperature or light condition. At high temperature and light condition, the bond is breaking like a homolytic cleavage. The homolytic cleavage means this carbon electron involved in this bond formation, hydrogen electron involved in this bond formation, 2 electrons existing in this bond. This carbon electron present here, hydrogen electron present here, the bond is breaking between the electrons. That is homolytic cleavage. So carbon existing with this electron, hydrogen existing with this electron, hydrogen leaving as the name is radical, free radical. So H radical, H dot simply. H radical is leaving, carbon radical is present. So that hydrogen radical is replaced by another radical in the chemical reactions. So one radical is replaced by another radical in the chemical reactions, that is substitution. So which is substitution? Free radical substitution. So alkanes are involved in which reactions? Free radical substitution reactions. Remember students, don't forget that. In the examination, alkanes are involved in which reactions? If it is asking, alkanes are involved in free radical substitution reactions. Free radical formation is possible at high temperature condition and light condition. Okay? Leave this alkane. Next come to the alkene. I am comparing here benzene, alkene and alkyne. In the benzene, between the carbon atoms, what is present? Double bond is present. Double bond. In the alkene, between the carbon atoms, what is present? Double bond is present. In the alkane, between the carbon atoms, what is present? Triple bond is present. So these hydrocarbons, alkene and alkyne, involved in which reactions? Benzene is involved in which reactions? Benzene is involved aromatic compound. First of all, benzene is the aromatic compound. These two are not aromatic, aliphatic compounds, open chain structures. So aromatic compounds involved in electrophilic substitution reactions. Remember, aromatic compounds involved in electrophilic substitution reactions, but these two are involved in electrophilic addition reactions. Now look at the alkene molecule. Between the carbon atoms, what is present? Double bond is present. One is sigma bond, another one is pi bond. Sigma bond is the strong bond, pi bond is the weak bond. You know that already. So something, any species, if it is want to come attack on the double bond. Example, one of the species is want to attack on the double bond like this. It want to attack on the double bond, want to looking on the one of the carbon, attacking on the one of the carbon. Remember students, between the carbon atoms, what is present? Electron density is present. Electron basically which charge? Negative charge. To that negative charge, which one is possible to approaching? Positively charged species or negatively charged species? If it is positively charged species, if it is positively charged species, attacking on the carbon is okay, possible. If it is negatively charged species, approaching is not possible towards the carbon. Reason? Between the carbon atoms already what is present? Electron density is present, negative charge is present. To that negative charge, which one is possible to approaching? Positive charge. Positively charged species called as what? Electrophiles. So electromeric effect it is. In the electromeric effect. So electrophile approaches towards the alkene carbon. Then double bond is converting into single bond after attacking. So it is which reaction? Electrophilic attack, adding. So electrophilic addition reactions. So alkenes are involved in which reactions? Electrophilic addition reactions. Remember, like alkenes, alkynes also involved in which reactions? Electrophilic addition reaction only, because of triple bond is present, negative charge is present. Negative, to that negative charge, which one is approaching? Positive charge, electrophile. Positively charged species are called as what? Electrophiles. So to that negative charge, that means towards the carbon, electrophile is approaching. Alkanes also involved in electrophilic addition reactions. Alkenes also involved in electrophilic addition reactions. But between the comparison, which one is more readily involved in electrophilic addition reactions? Alkenes are more reactive compared to alkynes. Reason? Here only one pi bond is present. Here number of pi bonds 2. Strength of the bond is more. For For breaking, more energy is needed. For breaking, less energy is needed. So reactivity, electrophilic addition reactions, alkenes are more. After that, alkynes. Alkynes are least reactive, alkenes are more reactive in addition reactions. Now come back to the benzene molecule. Like alkene, between the carbon atoms, double bond is present. But this double bond is not involved in addition reactions at normal conditions. Different conditions are needed. So, and also this double bond is a stable double bond. Reason, alternative double bonds are present, that is the conjugated system, conjugated double bonds, aromatic system. First of all, it is aromatic pi bonds are stable, not like alkenes. So these double bond is involved in the resonance. Only breaking here, hydrogen is, this is the hydrogen. Hydrogen is leaving as a H plus. Why hydrogen is leaving as a H plus? Carbon and hydrogen, carbon is the more electronegative element. One of the electrophile want to attack on the carbon. One of the electrophile want to attack on this carbon like this. One electrophile want to comes to the carbon, benzene carbon. This hydrogen leaving from this benzene carbon as a H plus. That hydrogen is leaving as a H plus. One of the species attacks as a electrophile on the benzene carbon. So this is what replacement. One electrophile is replaced by another electrophile. That replacement is the electrophilic substitution reaction. So benzene molecule involved in electrophilic substitution reaction because of pi bonds are stable. They are not involved in chemical reactions at normal condition. These are involved in electrophilic addition reaction. Alkane molecule involved in free radical substitution reaction. Free radical substitution, electrophilic addition and electrophilic substitution reactions. Now leave these molecules. Next take that one of the different molecule I am taking here. Look at this different molecule. This is derivative of hydrocarbon, that means alkane, derivative of alkane. Here carbons are present, around the carbon hydrogens are present, CH3, here it's CH2. Carbon connected with, for suppose consider as chloride, chlorine or bromine, halogen. So you know that already carbon and chlorine, carbon and fluorine, halogens are more electronegative element. So this breaking is the bonding electrons shifting towards this halogen, bonding electrons. This bond is breaking, the bonding electrons moving towards the halogen. Towards the halogen means halogen is leaving as a, along with the electrons as a X minus. X minus. Halogen is leaving along X minus along with the bonding electrons. Carbon getting which charge? Positive charge. So carbon getting positive charge means that electrophilic carbon is attacked by negatively charged any other species. So this is negatively charged species are called as what? Nucleophiles. One nucleophile is replaced by another nucleophile. That is what? Substitution. So nucleophilic substitution reactions. So alkyl halides are involved in which reactions? Nucleophilic substitution reactions. This is alkyl halide. This molecule is alkyl halide. That halogen is left as X minus. That position is occupied by another nucleophile. So this is nucleophilic substitution reactions. Okay na students? I hope this way of giving the explanation, maybe it is useful to you. I hope you are understand. If anyone not understand, please message me. Okay students, bye students.